37.07% of the people were faster than me.
37.07. Okay.
So I could sit there and say, if somebody else was in the race, what was the probability that they beat me?
I had the Z-score.
37%.
Oh, I would just say
Okay.
37%. Okay.
Yeah, because 37.07 is kind of close to 37, so I would round it off.
Oh, right.
Yeah.
So if I took another crew, what is the probability that I beat them? If I just picked another crew? 63% probability that I beat A if I just randomly picked a crew. Okay? So that's where this starts coming out to be like probability. If I know how I did, and I just picked some other boat, what is the probability that I beat that boat? 63%. Or, yeah. What is the probability that that boat beat me? 37%. Because the probability that they either beat me or didn't beat me, what is the probability that they did the exact same time as me?
Doesn't say
Zero.
Right.
Zero.
Yeah.
The probability of any given time is always going to be 0.
The probability of any given time.
Yes, if I put an equal sign on a continuous probability, the probability of any specific time is always 0. I can only do the times faster or the times slower, or the probability to the left or the probability to the right. The probability that I land on that spot is basically 0.
Because you're the only one who scored that time, basically. 'Cause in a race, it's really hard to say exactly that same time.
It's just a continuous probability. The time of any given probability happening is so slim, it's just
Okay, so
0. Okay? Randomly picking anybody who matches my time. They'd have to tie me. We'd have to cross the finish line at the exact same time. That almost very rarely happens. You think about a race, somebody,
right.
they can just, the chances of a dead heat, they call that a dead heat, is basically 0. It happens once in a blue moon. So that's all that we're talking about, is looking at different probabilities. So when I start looking at different things, that's what we look at. Where's my pen go? Where'd my magic pen go? There it is.
So you just need it official.
Let me see. How many minutes would 3 hours be?
128.
Yeah.
128.
How
I
many
mean,
minutes would
180.
180,
It doesn't sound
128.
right.
180.
Is 180
80 minutes.
minutes. Okay? So, if I wanted to know this, what is the probability that somebody finished in less than 3 hours? Or not less, I wrote the wrong symbol. Less than 3 hours.
So am I supposed to be able to look at this and figure that out, or no?
So we should be able to look at this table and figure that out.
That says 3. Where's the 3?
180
180.
minutes.
180 minutes.
Oh.
Because when we look at this, so if I want to know what is the probability that somebody finished in under 3 hours? Well, what was the mean?
What are we using?
For the race.
Oh, we're using the race again.
What?
368.43.
368.43.
43.
What was the standard deviation?
48.31.
48.31. So if I wanted to figure that out, what is the probability of somebody finishing in 3 hours? Well, then that's what I'm going to calculate my Z.
You don't need the time?
It's 180.
Oh, you're using that time.
What is the probability that somebody finished in under 3 hours?
One 368.4.
And when I do that, what do I get?
48.31. Need a calculator.
Yeah, you need a calculator.
172.373.
Minus
172.3.
188.43
And that would be a negative. Divided by,
Okay, wait. I got something up. Oh, okay, I see. Yeah, I got 188.43. Did you get 188?
Got 188.43.
I got negative 188.4307.
It's 3.900.
Wait,
We did 180
Oh, yeah.
minus 180
Yeah,
minus
minus.
368.43.
And when I do that division, what do I get?
I got 3.90.
I get a negative
Oh, negative
3.0.
90.
0.
So that's the Z-score. So what I'm going to do is I'm going to go to my Z table and I'm going to look that up.
Okay.
So negative, and now here,
Negative 3.
yeah,
my Z table only goes to
.4.
negative 3.4. And at negative 3.4, what do I get? 0.003. So basically what I'm saying is finishing under 3 hours is almost next to impossible. It's it's so small I can't deal with it. So let's change this.
Wait, I don't get. I must be missing something. How is this? How is negative 3? So I know the negative 3 part.
Because the area under the curve is always equal to 1. And we equate area to probability. So this is just telling me how much is under the curve. And at that point, I picked a number that's so far ridiculously small that it's just 0.
No, I guess I don't understand where's this. Okay, so this negative 3 has nothing to do with anything. Nothing to do with this.
No, that's the number that I just looked up here.
On the table.
That's my Z-score.
That's the
But
negative
it doesn't
3.
have a Z-score
Oh.
that small.
Oh.
So let's redo this.
Oh.
I picked a number that was too ridiculously small. So let's say that we finished under 4 hours. So if we finish under 4 hours, how many minutes would that be? 240. So you're always going to have to pay attention to sort of units, because my mean is given to me in minutes. If I gave you 4 hours here, you'd have to think in terms of minutes. So then this would also be the probability of being the time less than 240 minutes. Because my mean is given to me in minutes, I gotta think of my time in minutes, not hours. So if I recalculate this, what do I get now?
128.43.
What was that?
Negative.
Negative 128.43.
And when I do the division, I get
Negative 2.6.
negative 2.658, which would round to negative 2.66.
Hold on, 315.
658.
Negative 2.
Since it's 2.658, whenever I'm dealing with z-scores, I just go to two decimal places. So I can now go to my table. And I'm going to look up negative 2.6. So I'm going to come down here. So here's the negative 2.6. My second digit is what?
6.
2.6. So there's my second digit. So I come down here to this column, which is 0.0039. So if I look at this, the probability that somebody is faster than 4 hours is 0.0039, which is less than 1%. So the probability that somebody finished a race in less than 4 hours is less than 1%.
Which is unlikely.
Very top crew, the Tahitians. Okay, but yeah, that's sort of what we're looking at is, so we want to just be able to calculate it, and sometimes those probabilities are very small.
It's not too
So
bad.
this table is the
Is
percentage.
the normal, is the probability.
Okay, so
It's
we
the,
try to
it's the
find the
area,
z-score.
and we're trying to find the probability. Let's do another problem. Let's say we have a group of people and we time them. Okay? And we say that it is normally distributed. So you're always going to have to pay attention to this when we describe how it is. So I'm going to say, these times are normally distributed. I'm going to say that somebody puts an assembly together. So that all that means is I'm going to time people putting something together. Okay? They have to assemble something. So we're working in a factory. People assemble things. Okay? So I'm just going to time people assembling things. Okay? So I do this a bunch of times. I sit there for like 2 weeks and I time people putting these assemblies together. And I get a set of times, and I just tell you that they're normally distributed. I might tell you in another case that they are uniformly distributed. We'll talk about that on Thursday. But tonight we're just talking about things that are normally distributed. Now the aspect behind it is when we start doing things in the real world, a lot of things are normally distributed. If I talk about harvesting grains, and I talk about the amount of how many bushels per acre we get. Huh? Bush, yeah. Basically, if I do it and I measure a lot of people, it will be normally distributed. If I measure the weights of people and I do it for everybody, most of the population